Today's lesson is the first day of data analysis. We're going to learn about data analysis basics and some functions on the calculator. So number 1 says, draw a line of best fit and estimate its equation. The scatter plot below shows the test scores of 10 students and the number of hours that they spent studying for the test. So if you look on your x-axis, you can see the number of hours. In your y-axis, you can see their test score. So as you can see, as the number of hours increases, their test score increases. So the longer they study, the better they did on their test. Well, it says draw a line of best fit. And that just means draw a line that best fits the data that you see. And it doesn't make a straight line. But what we're trying to do is sort of draw a line through the heart of the data, through the middle of the data. So if I had to draw a line something like that, and yours could be slightly different, but it's still, you're trying to have the same number of points above the line that you do below the line, and you're just trying to draw your line through the middle of the bulk of the points. And then it says estimate its equation. Well, in Unit 3, that's all we did was write equations of lines. So if I were trying to write an equation of this line, let's check out my multiple choice. Well, his y-intercept is a 6, and his is a 60, and a 60, and a 60. So let's see what makes sense. Does a y-intercept of a 6 make sense, or a 60 make sense? And it's a 60. So A's out. My slope is positive, and the remaining slopes are positive also. D has a slope of 33. Point that one out because it's the biggest. And that means 33 over 1. So that means up 33 and over 1. Well, if I start here at 60 and I go up 33, there's 10, 20, 33, and over 1, that's definitely nowhere near where I am. So I'm going to cross him out. C's slope is a 3.3, so that's 3.3 over 1. So if I erase my dots before, if I go up 3.3, that would be like to here and over 1. Up 3.3 and over 1. Up 3.3 and over 1. It seems to be pretty dead on it. So I like this one. 0.3 over 1. Now that's up a tiny bit and then over 1. And I really think that that's just going to be too flat for this line. So we're going to go with C. Again, we're estimating. So you're drawing the line that best fits the points, and then you're estimating the equation that fits that line. So then we want to know, instead of us having to sit here and kind of estimate and figure it out, our calculator can find it exactly. It says the table below shows the cost of a sub sandwich based on the number of extras ordered. So the more you order on your sub, the more expensive it's going to be. So our table has the number of extras and then the cost of our sub, and it says which function represents the cost of a sub sandwich. Well, back in Unit 3, we could do y minus y and x minus x and find our slope, and then we could pick a point and plug it in and find our y-intercept and all that wonderful stuff. But our calculator will find it for us. So, oh my gosh, why do we have to find it by hand if our calculator will find it for us? Well, part of your exam is calculator inactive. So if they gave you this on that section of the test, you would need to be able to do it by hand. But if it's on the calculator active part, you can obviously do it on your calculator. So the first thing we're going to do is going to go to our Stat button, which is in the middle. We'll turn our calculator on first, and then we're going to go to Stat. I want Edit, so I'm going to hit Enter. I have data already in here from a previous problem, so what I want to do is clear it out. So I'm going to use my arrow button, get up on the L1. Do not hit delete. I'm going to hit clear, enter, and it should clear that data out. And then I need to type in the data that I have. So I have 1, 2, 3, 4, and then I use my arrow button to get over to my L2, and I have a 5.5, a 6, a 6.5, and a 7, and then I'm going to quit. I'm going to go back to stat. Now that I've edited, I want to calculate, so I'm going to go over to calc, and I'm going to go down to number 4, which is linear, because we're a straight line, regression, and that's just the type of equation this is. It is a regression equation. So I'm going to go to number 4, and I'm going to hit enter, and hit enter one more time. It gives me a whole bunch of information. The first thing you see is y equals ax plus b. That's the same thing as our y equals mx plus b. Then they tell us the value of a, which is 0.5, which is our normal m, our slope, and a y-intercept, which is our b, which is 5. So our equation is y equals 0.5x plus 5. Now all I have to do is come down here and find it. You have to be very careful because there are lots of 5s. So I need a slope that's a 0.5x, so I like that. I like that. C is out. I like D. And a y-intercept of 5. I like that. He's out and his is 0, so he's out. So it's A. Table below shows the cost of coffee based on the number of extras ordered. So you can go to those fancy coffee places and get a double espresso shot of whatever are all in your coffee. And so the more you put in it, obviously the more it's going to cost. So again, we're going to use our calculator. And if you'll recall, we went to stat. I'm going to stay on edit because I need to enter in my data. I need to clear out my L2, so use my arrow button and get up on the L2 and hit clear, enter, and then go over to my L1 and hit clear, enter. And then I'm going to type in 1, 2, 3, 4, and $2, $2.75, $3.50, and $4.25. Okay, and then I need to quit. So second quit. Now that I've got my information in there, I need to calculate the equation. So I'll go to stat, go over to calc. Remember what number we go to? Number 4, linear regression. Hit enter again, gives us a whole bunch of stuff. And I know you see these R's here. We're going to talk about those in just a second, but right now we're just trying to get the equation. So there's my y equals ax plus b. A is 0.75 and my b is 1.25. So then look at your multiple choice and see if you can find one that has a slope of 0.75 and a y-intercept of 1.25, and the answer is A. Okay, so now that we know how to figure out the equation on our calculator, we're going to talk about how closely these lines cut through these points and how tight your data can be. So right now we have 4 different scatter plots. 2 of them are positive and 2 of them are negative. The buzzword right here is correlation. We're looking for how closely the data correlates. So if I look at the difference between the top 2, they're both positive, but you can definitely see that in the first one, the points are much more close to the line. The data is more tight, so it is a stronger correlation, kind of like a magnet. And in the second graph on the top right, it still has a positive correlation, but you can see that the data is more scattered, a little more loose, and so that it has a weaker correlation. It's still positive, but it's just weaker. If you look at the bottom 2, they are both negative because they are headed down. Think about just like a slope. So on the first one on the bottom, that is a super, super strong negative relationship. Very, very rarely do you see points that are exactly in a row when you're talking about a scatter plot. So that is a super strong negative. And in the second example, they are more scattered. So you see a weaker negative relationship. So don't think of positive as being a good thing and negative as being a bad thing, because that's not the case. A positive relationship just means that as one variable is going up, so is the other. The more items I order on my pizza, the more expensive the pizza is going to be. So as something goes up, the other something goes up. But you can also have a negative relationship that doesn't necessarily mean it's a bad thing. The more hours I work out at the gym, the less I weigh. That has a negative relationship. Just because if something goes up, something else goes down. It does not mean that it's a bad thing. So I can have a positive relationship or a negative relationship, and then I just need to focus on the strength. So strong means that those points are tight to the line, like in this one and this one. And then I can have a weaker relationship, which would be like these two, where the points are a little more loose, not quite as drawn to the line. So if we look at this graph right here, it says the scatter plot below shows the number of division errors students made on a test and the amount of time they took to take the test. So the number of division errors and the amount of time. So you would think that the more time they spent on a test, the number of errors would decrease. And that's true. If I were to draw a line, it would look something like that. And so this is a negative relationship. Again, not a bad thing. It just is a negative relationship because as your time goes up, the number of errors goes down. So let's see. We've already decided it's going to be a negative relationship. So it says strong positive. It's not a positive relationship. Strong negative? Yes. Well, the negative part at least. Weak positive? No, it's not a positive relationship. Weak negative? Yes, we're negative. So it's either B or D because it's a negative relationship. So now you have to decide if it's strong or if it's weak. Well, look at these points in relation to the line. And again, think of the line like a magnet. How close are these points to that line? If they're drawn relatively close, then it's going to be a strong relationship. But if they're really scattered, it's going to be a weak relationship. These points are all extremely close to the line. So I would say this is a strong relationship and go with B. If your points were a little more loose, like this, now we're talking more of a weak relationship because the points are more scattered. Okay, examine the scatter plots below. The axes all have the same scale. Which plot shows the weakest correlation between its two variables? And again, it's not talking about positive versus negative. It's just saying which one is the weakest, the most scattered. What do you think? I think it's B. B is definitely the most scattered because the points are more scattered about, so it has the weakest correlation. Do any of the plots illustrate a negative correlation? If so, explain your response. Well, A definitely looks like it's headed in a positive direction. B's kind of scattered all over the place. Let's come back to him. Look at C. C is definitely headed in a positive direction. And D, although D is a little bit loose, it is definitely headed in a positive direction. Let's look at B. I really think that this, especially if you look at this point right here, and I could draw a line, and although it is scattered, they are following a negative direction. A positive line would definitely not work for this. So I'm going to go with B. Harder to see because it's a weaker relationship, but I think it's definitely headed in the negative direction. Which plot shows the strongest correlation? Again, doesn't have to be positive. I just need it to be strong, tight data. The answer there is C because it is the tightest to its line. The scatter plot below shows the annual salaries of 13 graphic designers and the amount of time they worked at their current job. Well, you would assume the longer someone's at their job, the more money they're going to make. The longer you're there, the more raises you should get if your job performance is good. And if it's not good, they're probably going to fire you. So you wouldn't work there very long. So it says, which statement is true? There is no relationship. So no relationship would mean that these points are scattered all over the place and that there's no pattern whatsoever. And that's not true. There is a negative relationship between the amount of time and the annual salary. And I just don't see these headed in a negative direction. If I were to draw a line through the heart of the points, it would look something like that, and that's definitely a positive direction. There's a strong positive relationship between the amount of time and the annual salary. Strong. I agree with the positive part, but the strong part, I mean, these points are a little loose. Some people have been there for a while and don't make as much as others. Part D says there's a weak positive relationship. I think this is more of a weak relationship, just because these points are kind of far away from the line. If you took those points out, then yeah, we would be stronger. But this is just a little bit more loose. It's not, if you think of this as a magnet, it's not quite as strong a pull to the line. So I would definitely go with weak for this one. Okay, so we've kind of had to eyeball and guess about our correlation and trying to decide if it's strong or weak. The positive negative part I think we can get, but the strong and the weak is tough. So we have what's called a correlation coefficient. That's an O. And it is an R. The letter is an R. And your R value is going to fluctuate between -1 and 1. So here's what happens. It will never go outside of 1 or -1. If your R is a 0, then that is a weak relationship. No relationship whatsoever. The points are all over the place. As you head towards a +1, they get stronger. But as you head towards a -1, they also get stronger. Remember, you can have a positive relationship or a negative relationship. That's just the direction of the line. But the strength can be the same at 1 or -1. If I'm a 0.5, that's a weak relationship. If I'm a -0.5, that's a weak relationship. But if I'm like at a 0.8 or a -0.8, then that's a stronger relationship because it's closer to either 1 or to -1. So let's look at these examples of these R's and let's talk about their relationship. So if my R is a -1, it is a negative relationship, but is it strong or weak? And that's strong. That's as strong as it can get. It's all the way to a 1. It happens to be negative, but it's all the way over to a 1. If my R is 1, then that's a positive, strong relationship. Again, as strong as possible. If my R is 0, then that is the weakest it can get. It actually means that there's no relationship between these variables whatsoever. Like if I was going to measure shoe size and hair length, those have no relationship whatsoever. So that would be no relationship. If my R is a -0.9, is that close or far away from a 1 or a -1? And that's super close to a -1. So that has a negative relationship, but it is really strong because it would be right there. Now, 0.05. How close to 1 or to -1 is that? Well, it's positive, so it's on the positive side. 0.05 is going to be about right there, and that's really, really close to 0. So this would be a positive, weak relationship. 0.8, again, would be about there. So that's a positive, strong relationship. 0.1, again, positive, but 0.1 is going to be about there. So it's positive, but it's weak. If you have trouble with the decimals, think about it in terms of money. A dollar, or a negative dollar, and a positive dollar are super strong. But if I have 0.1, that's like having 10 cents. That's really far away from a dollar. But if I have 0.8, that's like 0.80 cents. That's closer to a dollar. If I have 0.05, that's only a nickel. That's really close to having nothing. And the same thing with negatives. If I have negative 0.9, that's negative 0.90 cents. That's strong because that's really close to a negative 1. So if it helps, think about it in terms of money. What type of correlation is shown in this table? So here they give us information about sugar and weight. And it wants us to tell what kind of relationship is. Now, this is not something you just kind of stare at and estimate. You take your calculator and you type this data into your L1 and your L2. So everybody grab your calculator, go to Stat. I want to edit. I need to clear out my L1 and my L2, and feel free to pause this video while you do that and type in your data. Type it in very carefully. Okay, and once you have your data typed in, you quit. You go back to Stat, go over to Calc, go down to number 4, hit Enter. All right, so it gives us the equation of the line with the A and the B, but that's not really what we're interested in here. It says what type of correlation. So it's looking for the R. So underneath the A and the B, you'll see an R squared, which we are not interested in, but the R, which we are interested in. So our R is 0.49. So that's like 49 cents. Now, is that positive or negative? It is positive, so we can take both of these out. But 49 cents, is that close to a dollar? Or is that more close to having nothing? And it's definitely not strong. If you think about 49 cents is going to be a little bit less than half. So I would definitely say that this is weak. Which of the following is the correlation coefficient? That's your R. For the linear model. And again, this is not something we sit here and stare at. We grab our calculator, go to Stat. We want to edit, clear out the data that you had in there before, and type this data in. And quit. Stat, Calc, down to number 4, hit Enter. And again, I'm not interested in the A or the B because it doesn't want the equation of the line, but I want you to notice if you'll look at choice D, which is a 6, which is your A value, and B, which is a 0, which is the B answer. I'm not interested in that. I want the correlation coefficient, so I want the R value, not the R squared, but the R, and our R is 1. So we're going with C. And 1 is the strongest it could possibly be. It is a positive relationship, and it is a 1, which is super strong. Okay, number 8, or number 9. The table below shows the amount of time 7 students studied for the test and their respective scores, which describes the relationship between the amount of time a student spent studying and their test score. So I want the correlation coefficient. I want to know what describes the strength of their relationship. So again, I'm going to go to Stat. I'm going to clear both of these out. And type both of these in. And then I quit, and I go back to Stat, over to Calc, down to number 4, hit Enter, and again I'm looking for my R value, and my R value is 0.959. So positive or negative? The answer is positive, so let's take out everything that's negative. So B and D are out. Positive, are we strong or is that weak? And think about how close that is to a 1. And that is super, super, super strong. So we're going with strong, not weak. Table below shows the number of hours Tammy works during 5 days and the amount of tips she earns. What best describes the relationship? So again, we're looking for the correlation coefficient. So we go Stat, Edit, clear these out. 6, 7, 8, 4, and 6. And the amount of tips she makes. Quit, Stat, no, Calc, go down to number 4. And again, I'm looking for my R value. So the R value is 0.91. So are we positive or negative? And the answer here is positive. So we can take out the negatives. And 91 cents, is that close to $1 or is that far away? And the answer is that's close. So this is a strong relationship. Which table best fits a linear model? If I'm looking for the one that best fits, then I'm looking for the one that has the strongest R. So what I'm going to have to do is go for each of these and find their R value. So thank goodness they're small. Quit, Stat, Calc, number 4. And his R value is a 0.9759, which is super, super strong. So if I had to bet, I would say he's going to win. But we've got to test him out and see. All right, now the 1, 2, 3, 4 stays. So I'm going to leave that alone and just change this 5, 15, 45, 100. Go to Stat, over to Calc, down to number 4. His R value is 0.952. So right now A is winning. So I'm going to mark out B. Stat, Edit. Both of our lists change this time. So 4, 6, 8, 11, and 2, 3, 4, 5. And his R value is 0.994. So who's winning now? The answer is C. So A is out. I thought A was going to win. All right, let's test this last one. 5, 6, 8, 12, -3, -5, -9, and -17. Oh, look at that. His R is a perfect -1. So who's stronger? A positive 0.994 or a negative 0.1? Remember, positive and negative has no bearing on how strong it is. The question is, how close is it to 1 or to -1? And D is a perfect 1. So even though it is a negative relationship, it is the strongest relationship. So he wins. Which table is not a linear function? So for this one, you want the smallest R value. And just to save us the time from typing it in, I'm going to tell you that this R is a 1, so that's perfect. This R turns out to be a 0. This one's a 1, and this one's a 1. So which one is not a linear function? And it would be the one that is closest to 0. So that would be him. If I had R's, let's say I had an R that was like a 0.92, an R that was a 0.37, an R that was a -0.8, and an R that's a -0.05. And I wanted to know which one is not a linear function. I want the R that's closest to 0. That's super strong, so he's out. This one is super strong because it's a -0.8, so he's out. Now he's very weak because he's close to 0, but so is he. Again, we don't care that he's negative. So which one is closest to 0? And that's this one, so he would be not a linear function. So two things today. First, we learned how to type our data into our calculator L1, L2 and find the equation by using y equals ax plus b, and it gives me the a and it gives me the b. So it gives me its slope and it gives me the y-intercept. So I can write an equation of data. And then we also talked about the correlation coefficient, which is how strong of a relationship the data has. Remember, it will always fluctuate between a 1 and a -1. Both are equally strong. The 0 in the middle, this is your weak relationship. But the closer it gets to 1 or the closer it gets to -1, the stronger that relationship gets. And again, that coefficient is your R, and it's called the correlation coefficient.